All right, so today we are going to do section 8.3 of inverse functions, where we'll be talking about this idea of inverse. Okay, and inverse means the opposite. So what we're actually going to do is we have seen things written like y equals 3x minus 4 before. We've seen stuff like this, where we have y equals blah or blahs with x's. And then we'll have some x's sitting inside of it. Well, what we're going to do today is I'm actually going to take this y and this x, and I'm going to completely flop. So I'm going to take this x and I'm going to put it in the y spot, and then I'm going to take the y and I'm going to put it in the x spot. We've never had anything like that before, because then the problem is going to look something like x equals 3y minus 4. We do not keep it as x alone. So what we do is then we solve for y. We solve for this y. Get it by itself. Okay? That is going to be the whole goal of today. That's known as an inverse function. Now there are a couple different things that we can talk about with inverse functions. Okay? The first thing that I really want to hit with inverse functions is, so let's write this out, inverse function properties. The first property that happens is the domain and range are interchanged, meaning completely flopped around. Okay? They are completely switched. The second property, okay, is the functions are reflected over the line y equals x. Now these two properties are very, very, very important because they help us create functions if we're given a certain set of points. Such as, so let's have an example here. An example, which this is going to be the only one that I am going to do. Okay. Say we have points 9, negative 6, 8, negative 5, 7, 3, and let's do one more, 4, 3. So we have these 4 points, and let's do the domain and range of the original. So the original here, domain, remember all the way back from chapter 1, or this is actually chapter 2, the domain, we have to have this curly bracket, are all the x's. And I'm supposed to put those in order. So that's what, 4, 7, 8, and then 9. Now, that's the domain. The range, then, of course, is the y's. Well, let's put those in order then. So the lowest one I have negative 6, then I have negative 5. And I have 3 come up twice, but remember, we only have to write it for 1. So there's the domain and the range of the original. These are the original. Now let's see if we can create the inverse. Inverse would then be the point, okay, so I look at 9, 6. I have 9, 6. Well, the inverse of that, I'm supposed to swap the x and the y, so this is negative 6, 9. Next point, 8, negative 5, well, that'll become negative 5, 8. Oh, 7, 3, that's got to be 3, 7. And 4, 3, well, now that's 3, 4. This is the inverse of that red thing. Let's see if we can't do the the domain now of the inverse. The domain of the inverse are these x values. That should look very familiar, as these values, these domain values here, should match the range values of the other. -6, -5, 3. Which, of course, they do. Well then, by definition, the range of the inverse should be the domain of the original. Well, the original was, what? 4, 7, 8, 9. Okay. 9, 8, 7, 4. Oh yeah, that's right. It's just, I have to put them in order. And there we have done our very first inverse. We found the inverse of these 4 points. You can see that the domain and the range have been turned around. Well, what about like the second property? Let's look, like the second property. Okay, this is a property. It says it's reflected over the line y equals x. Well, all right, my original topic, we just had it, that was 9, -6, 8, -5, 7, 3, 4, 3. Let's see if we can't graph it. Okay, let's see if we can't graph it. So 9, 6, well, let's see here. I need one more here, 9, and then up there, 8, 5, 1, 2, 8, 1, 2, 3, 4, 5, down here, 7, 3, 4, 3. Those are my original points. Now, it says that it's the line y equals x. Well, that is of slope 1, 1. Now, of course, this is not the best graph here that I have going on here, because I did not draw it to scale, unfortunately. But if I try to draw this sucker, according to my scale, gosh, it's just not a very good line. Maybe I should try to redo my graph here. This is not a very good graph right now. Let's try to redo this a little bit neater. Need all the way to 9. I need up to 3, it looks like. And I need down to 5. So let's see if I can't redo this a little bit better. There's 4, 3, 7, 3. Be up there. 8, -5. Be down here. And then 9, -6 would be way down here. And then my y equals x line, this thing, would look something similar to this line. Now what should happen is when I go to draw the other inverse points, which were -6, 9. Oh, -6, that'd be 1, 2, 3, 4, 5, 6, and then 9. That's way up here somewhere. Now that point, if I were to run it down to my line here, and then reflect that line down to here, I should hit them. Just like this. Okay, let's try another. This 4, 3 was 3, 4. Okay, so this point here, if I ran right to here, then that same distance that I run over this way should give me the next point. Well, that's at 3, 4. And that's what it means by reflection over the y. I'm not going to continue the whole example. That should be pretty clear. Next type of thing that I want to get into is this idea of inverses. So if I gave you an example such as f of x equals x squared plus 5, and now I make the statement, find the inverse of, and then I want to find the inverse. Well, let's write some steps over here on the side. So steps. First step, replace f of x with a y. That shouldn't be too bad. Okay, so I come over here. I want to replace this f of x right here with a y. So that's y equals x squared plus 5. My second step is switch x and y. Okay, let's see what that looks like. I have, right now, y equals x squared plus 5. Well, now I want x equals y squared plus 5. Notice I did not change anything else. I just simply swapped. Our third step is to solve for y. Okay, to get y by itself here, I would need to subtract 5, so that's x minus 5 equals y squared. Get rid of that y squared, I would need to square root it. Then that's y equals the square root of x minus 5. Notice I have gotten the y by itself. But in the original problem, we did not have a y. So I need to replace y with f inverse of x. That's how you say that with that negative 1 then. So if I'm going to finish this problem, it's f inverse of x equals the square root of x minus 5. And that is my solution. There's one example. Let's do one more. Maybe we'll make this one a little bit harder. So let's call this one g of x equals 4 plus the cube root of 2x squared minus 5. First step. Okay, get rid of this g of x, make it y. Second step, replace or swap the y and the x. So that's x equals 4 plus the cube root of 2y squared minus 5. Then I am supposed to solve this sucker. So the first thing I need to do is move this 4. That's x minus 4 equals the cube root of 2y squared minus 5. Then I will get rid of this cube root. How do you get rid of a cube root? Well, I have to cube that. Well, if I do that to that side, I have to do it to the other. So that is x minus 4 cubed equals 2y squared minus 5, because of course this cube root and this cube cancel. Then I need to move 5, so that's x minus 4 cubed minus, this was minus 5, so this is going to be plus 5 equals 2y squared. Do not try to make the 4 and the 5 combine. Then I need to divide by 2. Okay, x minus 4 cubed plus 5, all divided by 2 equals y squared. And finally, I can square root it. What you do to one side, you must do to all of the other. Y equals the square root of x minus 4 cubed plus 5 all over 2. And unfortunately, I'm not quite done, because I can't have this pesky y here. So I have to get rid of it. Well, what should I get rid of it with? The original equation up here was g. So that means this is the inverse of G, G inverse of X equals, and then I have X minus 4 cubed plus 5 all over G. And there we have our answer. Those are going to be the only two problems that I show on how to actually calculate the inverse. The next thing that I'd like to do is I would like to prove or show if two things are inverses. So verify / prove two functions are inverses. To do this, we must show f of g of x, and I guess I should, up here I should say two functions. We'll call one f of x and the other one g of x. So f of g of x equals x, and then I also must show g of f of x equals x. This absolutely needs to be written in your notes. This is how you go about verifying things are inverses. I am supposed to take g of x and plug it into f of x. After I work everything out, I should get just an x. Then I'm going to turn around and take f of x and plug it in to g of x. And I better just get an x. So let's see how this is going to work. Here's an example. Let's start with f of x equals 2x minus 6, and g of x equals 1/2 x plus 3. And my goal here is to verify f of x and g of x are inverses. So I have to show two different things. I have to show f of g of x equals x, which means that I have to take g and plug it into x. Well, that would be taking g, this whole thing right here, and plugging it in to x. So let's write that out. That's what? 2 times something minus 6. Well, that something is that 1/2 x plus 3. Now I'm supposed to work it out. If I take 2 and I distribute it in here, 2 times 1/2 x, I think that's just x. 2 times 3, that'll make a positive 6, and then I drop this negative 6 times. Well, x plus 6 minus 6 is just x. Is this what I wanted to show? Yeah, it is right here, so I put a little check mark. That didn't seem too bad. Now, if it worked out there, I can't just say that they're good to go. I have to check the other side. Other side is g of f of x equals x as well. Well, in this case, I'm going to take f of x and plug it into g. F of x is this guy right here, and I'm plugging it into g right here. So let's see how this is going to be written. Well, g was 1/2 times something plus 3. What's the something? Well, the something is the 2x minus 6. Now I go through the same type of process. I'm taking this 1/2 and distributing it. 1/2 times 2x is x. Okay, 1/2 times the negative 6, I think that's negative 3 plus 3. Those cancel, I get x, and I want x. Yes, so I put a check mark. Now, because they both checked, I have two check marks. What does that mean? Well, that means f of x and g of x are inverses. If you get anything but x for both of them, then we say that they are not inverse functions. Okay, we say they're not inverse functions. I think I'll do one more example and then that'll conclude the notes here. So one more example. Let's try this one here. Let's try f of x equals the cube root of 3x minus 7. And looks like g of x equals x cubed over 3 minus 7. So let's revisit again here. What do I have to check? Well, I have to check f of g of x, and that has to be equal, which means I have to take this g of x, plug it into f, which means this thing right here has got to be taken and plugged in to f. Well, f is the cube root of 3 times something minus 7. The something being the x cubed over 3 minus 7. All right, let's see if we can work this down through now. If I distribute this 3 and the bottom 3 there will cancel, that's just x cubed. 3 times that negative 7, that'll make negative 21. Drop this 7 down, and it's all still under the cube root. X cubed, negative 21, negative 7 is negative 28. And then I feel like I'm stuck. I can't get anything else to cancel. Well, did I get just an x as I indicated I wanted right here? Oh, of course, you say no. Well, if I didn't, do I need to check the other side? No, because both have to be x. So because I say no here, I can say g of x and f of x are not inverse functions. And then that will conclude this video. I am not going to go through any more examples. I do have written examples and a static copy on my site as well. Please feel free to look through there. These should not be the same examples as those, so you can see some other ones and how to do it.